on the circuit sheet. 2b is a little bit more complicated than 2a was. This time we've got a variable power supply. That's all that means, is that it could be adjusted to different voltages. At the moment it's set on 10 volts. We've got 7 ohms here, and then again we've got some parallel bits going on here. A little bit more complicated this time because we've got 2 resistors in this parallel arm here. So the first thing we're going to do is combine them. So even though this arm is parallel to that arm, these two follow each other one after the other. So that's a little series bit. So it's just resistance is resistance 1 plus resistance 2. So it's 3 plus 3, it's 6. All right, so we're going to replace that with 6. So now what we've got is 6 6. Right. That was a 7. So now we've got 6 6 just in parallel. So we replace that. So you get 1 6 plus 1 6, which is 2 6. So when I get the reciprocal, it's going to be 6 over 2, which is 3. Alright, so now I've got something like that. This is 7, this is 3, and this wild looking battery over here is putting out 10 volts. Alright, so they're just in series. 7 plus 3, 10. So I've got 10 volts, 10 ohms. All right, so now I've got the total resistance for the whole circuit is 10, and I've got the total voltage. The total resistance was 10. Total voltage is 10 volts. So V equals IR, the current that's able to flow in that circuit, is 10 divided by 10, 1 amp. So I've got 1 amp of current able to flow through the circuit. That means 1 amp goes through the 7 ohm resistor, because all of the current goes through it. But when it gets over here, it's going to split up. Now there's 6 ohms of resistance in this arm, 6 ohms of resistance in that arm. Because they're equal, it will split evenly. So it's just going to be 0.5 amps through the 6. And these 2 3s will also have 0.5 go through both of them. Right. Now, voltage drop across the different parts. So if we go over here, we've got 7 ohm. If we look at the 7 ohm resistor, resistance is 7 ohms. The current that flows through it is 1 amp. So V equals IR, 7 volts. So 7 volts is going to get used in this 7 to start off with, which means we have 3 left to go through this. There'll be 3 volts across either of those. Right, so the 6 ohm, I'm just going to write there, that's a parallel. 6 ohm is going to have 10 volts minus 7 volts, 3 volts go through it. What about the 3 ohm? Because some of the energy will get lost in here and some of the energy will get lost in here, and it will add up to 3 volts. So I'm going to predict it's 1.5. All right, now we know the current in those was 0.5. So let's do it that way. V equals IR 0.5 times 3 gives me 1.5. So 1.5 volts would be lost in the first one, 1.5 volts in the second one, so 3 all told, which is what it should be. 3 volts across that one and 3 volts across this, half of which goes in that one because these are equal size. Half of the energy will be lost here, and the other half will be lost here.